Okay, so we're live. Okay, I think we've signed into chat. So we'll just little chat box here. Hello all. So we started a little late. I'm going to pull up some stuff to help us along the way. And we should be good. Analytics. Okay, so let us reset this. So today we are going to present or talk about the Kira design FPGA art development FPGA AI starter kit. And the lead time is currently 12 weeks. I bought mine about 8 weeks ago and it got in the mail yesterday. You can see it on this camera here. Like that right here. We have the Kira, we have the SOM right here, and then we have we call it like a daughter card. What do they call it in this situation? A kit, okay? A kit. And we have the Kira SOM module, the Kira K26 SOM module. And the Kira FPGA is a modified MPSoC Zinc UltraScale Plus FPGA. They don't really go into much. I mean, they just say Zinc here. But if you read the documentations, there is a little bit, they did do differences to this FPGA for the SOM. I'm not too privy on those details at the moment, but we are going to go look at the hardware design. Well, first we're going to run the module. So, I mean, we can go through this, let's go walk through the starter user guide, right? This what we want. I was using another one earlier. Initial boot commands. Okay, yeah, they have a better guide. Where is their getting started guide? Right here, getting started guide. So it's really basic. You set up the SD card image using different tools. I really like this tool, so it wasn't too hard. You connect everything that's given. We have on mine, we have a keyboard. This is a USB webcam, not very good. Ethernet, and we have a HDMI capture device here, so you can see the output. So in the top right corner, you see a little black square. That's the output of the HDMI at the moment. And if we could zoom in, you would see the little letters. It's at 1080p at the moment, so it's hard to see what's happening. And then we have, yeah, just the UART and Jtag is over here. Can I show off? Do I have my... I don't think I have it, but let's pull it up real quick. So if I pull up the Tickle console, so let's go ahead and look at the Jtag real quick so we can see what device we have on here. We know it's connected. This can be useful for debugging. So we're going to pull up XSTP, the debug device. We're going to go connect, right? Then we hit targets, and we have a PS and a PSU. With all that looks like a traditional MPSoC. Now let's look a little bit more into it. So if we do Jtag targets, we see that we have a Xilinx X LMSC, and normally you would see like MPSoC or Zinc UltraScale Plus here. So this is definitely a modified FPGA that is not well known to this system. So let's see what happens if we pull up the Tickle for 2021.1. So this is the brand new Vivato that came out. So let's see if this gives us any different information on Jtag. I'm just curious. So let's connect. And so we do targets again. There's nothing new. If we do Jtag targets. Okay, so now it does recognize that this is a Kira FPGA. So now let's let's move on to the more interesting stuff. Booting the starter kit, it talks about baud rate, giving yourself sudo use, and then it talks about setting up these applications. And this was a little complicated. These instructions are somewhat helpful. Let's see. You want to use the UART and not SSH for this, because this command right here works over UART. It's hilarious. So let me show you. We pull up. We have a UART terminal right here to the device, and we have a SSH window. Right. And I minimize the things at the top? I guess not. Okay, so if I type in list apps, it lists it in the UART. Like, it does it down there. So if I do sudo xmult list apps here, it actually presents it down here. So you might want to use the UART. We're going to use the UART for now. Use the UART when you're going through their tools. It's kind of expected to do the UART. So I already have the smart camera loaded. So what we're going to do is we're going to go show how it works. We're going to do this right here, this command. And it's going to use the MIPI camera, which is this little guy right here. Unfortunately, I don't have it stabilized, so it's going to be very wobbly. So the video might be a little bit jarring, but it's going to do 1080p resolution, 30 frames per second, and it's going to output DP. It does say DisplayPort, but there's a, I believe one of these chips is a video splitter, and it's the same output goes to DisplayPort as it goes to the HDMI, so you can use either or. So copy this command, load it here, run, and okay. In the top right corner of the video, you'll see there should be a blue bounding box around my face. And that's it's just doing facial recognition with its AI interface and whatnot. So we have an example, and there's more information here. Well, we're going to dig down into the architecture, and then we're going to look at the Vivado projects for this design. So let's go look at a little bit how this works. So they're using this much bigger software stack than I'm used to, and I feel like I need to catch up with what's happening. Because, let's see, I'm comfortable with the hardware portion. I don't really know what they're doing here and how they're putting the AI stack on top of that, the user level and stuff like this. I'm not too familiar. This is where mostly I am comfortable with understanding. So they have this application, video. Is there anything really important here? No, this is not my forte, so I don't really know how to give a good explanation for this. So let's just see if there's anything else we can talk about here. No. Okay, so let's go. We'll get to the hardware. I just want to make sure if there's anything here worth talking about. And talking about the pipeline. Okay, so let's just talk about what I can talk about here. So we have the architecture. We have our MPSoC design. We have a processor system right here with the those inputs on those, or I guess outputs on those sides. Then we have the programmable logic, and they split up the hardware design into. Oh, I might go turn off that camera. That is such a jarring little camera. It shakes as I talk. So we're gonna turn off that camera for now. But so the blue portion here is something that it's part of the platform of the PL, and the green portion is part of the overlay. And from what I understand, the blue portion is created with Vivado, and then the green portion is created with like Vitis AI to help out. And we're gonna break down into the Vivado project and look through this information and understand kind of what the hardware side looks like. I'll need to dig a little bit more into how Vitis AI works to be able to figure out how the green portions are generated. We'll look into what the hardware part of that looks like in a few seconds. Is there anything here? We talked about the accelerator structure. So this is what's generated with the Vitis software, and it generates it's almost like a high-level synthesis or like a predefined HDL where they change the configurations. At least the DPU is, which is the deep learning processing unit. Talking about resources. Okay, so let's actually go dig down into the meat of this. So there's some AI stuff. I need to go. So I need to. This is something I'm unfamiliar with. So I need to open up Vitis AI and actually look into how this works and do some Vitis AI tutorials. So probably in later videos, I'm going to sit down and we're going to go through some Vitis AI tutorials to figure out how we can make a custom AI application and put it onto this board. So building the components. So the platform is what we said earlier, is kind of like the Vivado project. And then they have this Vitis project, which creates the accelerator, kind of like an HLS design, creates the accelerator and places it into your design here. With Linux. So what we're going to do first is we're going to open up Vivado and we're going to look at the platform, right? So we're going to look at the platform. So let me open up that Vivado project. Okay, it looks like we got disconnected from. So we're going to want to go here, and I need to go open up Vivado. Vivado's up a little bit more. This is me. My investigation of this project has been interesting, to say the least. Going through these build scripts, I found a few issues. I don't know where to really post them, but a few things I had to get around to get these things built properly. Okay, here we go. So we kind of have three projects, right? We're going to have, this is the platform, this is the overlay, and this is the DPU wrapper, which is interesting. So we're going to start with the platform. And sorry, I'm doing this over SSH tunnel exporting because this is running on my Linux machine. It had the available space for a whole nother version of Vivado. Oh, make sure you have Vivado 2020.2.2. That's the newest or the oldest version that supports this. You can try, or that's what their repositories are open for. So what we're going to do first is we're going to open the block design and we're going to walk through this the platform. We're going to walk through what the platform, the Kria design is. And if you have any questions, feel free to ask. I know that the YouTube streaming is a bad latency for like having good dialogue, but we can at least try to answer some questions. So we're gonna make the diagram to full screen, minimize the flow navigation. This is our block diagram. A little hard to see the names. Let's see, if I turn this to interface view, is it still... let's change it to the default view. I like that. So what we're going to talk about is the zinc real quick. So let's zoom into the zinc real quick. You'll notice, so we have 3 master ports and most of the slave ports open. These are cache ports and these are high performance ports for the APUs and a low performance port for the A5s. Or the R5s. Let's interrupt lines. So most interesting thing is these things are not connected. These will be connected in the overlay stage when the Vitis AI. I'll show that in the next project. But these will be connected to the accelerators, the AI accelerators, in the next portion. So we're going to open up this guy. Hopefully it doesn't take too long. And I want to look at what configurations or settings we have in this MPSOC configuration. Okay. So anything interesting? GPI, QSPI. We have internet, USB, the SD card, not SPI, URC, and most of the connections. I don't think there's anything worth talking about here. But this is using the board configurations to get the correct configurations up and going. They did a preset. Interesting. So let's move on to what else is happening in the platform of this design. So these are clock and reset neck structures. This is a interconnect that is connecting the capture pipeline. So this is probably connected to one of the master ports. Here, so this is on the full power domain, and it's connected into our capture pipeline. So let's look at the capture pipeline first. So this is connected to the MIPI camera. So over here we have the MIPI PHY interface, and it's going into this sub block diagram. I'm not sure if you guys used block diagrams before, but this is kind of just a hierarchy system. So right here we have a MIPI system. This looks like a Xilinx IP block. I haven't used it before, but it looks like it's something that's just part of the IP repository. And so the PHY interface, that's the input for the video, and then there's an AXI bus. This AXI bus that allows you to control this support. Is there anything worth noting here? This does support 4K image, which is pretty cool. 4K at a lower rate. You can do application projects. Pretty cool. But interesting that they have a pin assignment here. Yeah, so this board configuration, you can pick which one. And on the ISP, that would do the pin assignment. If you have any questions, you can always go to the product guide, which will open DocNav, and you can see more details about this IP. So it's then processing the video, and it's setting it to this data FIFO, just so you know, actually stream FIFO. And it's going through this subset converter, which is probably just changing the width of it. Let's see. Yeah, going from 4 to 6 bytes width. I like to pack it a little bit better. And then we have a frame buffer. So this is something that's created in Vivado HLS. I'm surprised it doesn't say Vitus HLS, and this is probably, let's see if we can hunt down the code for this real quick. So if we go back to this repository right here, we go to platforms, show you where you can find this, where this is stated, Vivado. We're going to the VCU right here, go to IP. Not stated there. Interesting. I wonder where this frame buffer is defined. If it's defined up here, the VCU though, that's not this frame buffer. If we want to know where the frame buffer is, what we can do is we can go to the Flow Navigator, and if we go to the IP catalog, we have these custom repositories. Interesting. Don't see the frame buffer. What's it called? I wonder how they're importing this video frame buffer. Double click it. A large window. Interesting. Bringing in the video, right? Or is that a standard? Maybe that's a standard IP that they wrote in HLS. That's interesting that it has the HLS icon on it. Okay, so let's go back to our main diagrams. And this is basically just converting the MIPI video into something. And you can look at the IP blocks individually in their documentation to understand those a little bit better. And then this video is going directly here. So that means that this guy is writing to direct addresses in memory. So this is acting as a DMA engine. This frame buffer, right, is a DMA engine. It's going directly to DDR. And the buffer control, that must, yes, the buffer control there. Okay. Interesting that this control is coming from something else. That's coming from a different interconnect. Okay, so they have that control is on a different interconnect, which is connected to the R5 processor. Oh, so they're doing some real-time. So this is all connected to the R5 processor. They're probably doing some real-time control of that. I do not know why they have. Maybe this is connected later to one of the accelerator control. Maybe this is connected to accelerator control later, and this is just a placeholder. So this verification block is not for operation. If you open it, it has a big red warning that says it's for verification only in a virtual part. Okay, that's about it. Fan enable. Oh, you can do speed control the fan. This is the audio for the built-in mic. And I'm not really used to this stuff. Clock converter, audio formatter, C transmitter, I2C receiver. Okay, so that's not terribly interesting. I mean, audio. Okay, so let's go look at the last part of this block, which is going to be the VCU, which is the ASIC portion of this that it allows you to video codecs unit, I think is what it's called. So we'll go video codecs unit. And the video codecs unit is definitely complicated. It has 3 different master buses that are going to the DDR. And I've talked to Xilinx people about this a little bit, and they admit that this is a complicated thing to use. So having this as an example is great to learn different uses for it. And this is they did say, I did read that the SOM does limit a few of the abilities of the VCU. That the data rate, since you only have a DDR in the PS and not like additional DDR in the PL, it can limit the features of this ASIC unit. Okay, so I think that's a good place. So this is what they call the platform. So it's basically connecting the processor to the video capture device, to the audio capture device, and also to the ASIC video codec unit. And it also configures the Zinc processor with the various peripherals like USB, DisplayPort, and Ethernet. Now let's go move to, I think, more of the interesting part, the part that makes this the Vivado AI engine. So once you go through the build script, so let's see, go here. So this build script builds that platform project. And then it exports it to a Vitis platform that's used by Vitis AI. This is a very simple thing, doesn't take long to run. And then it does this using Vitis AI. It creates a overlay, and it actually creates a new Vivado project where it inserts the accelerators to the appropriate interfaces. So if we go back to the top, here we go to overlays, we go to examples, smart cam, and if we go to project configuration, this is really, so this tickle script strips the original I/O, and that strips the I/O, and then here inserts it, right? So we have the DPU is going to be connected to high performance 1, high performance, those AXI ports, and then the pipeline accelerators are going to be connected to these AXI ports, and we'll see that in a second when I open up that Vivado project. And yeah, so you run, somehow Vitis runs in the background and generates this. So if we go to open recent, we're going to go to project. So this is after the accelerators have been added to the Vivado block diagram. And we'll talk about those accelerators, and maybe we can walk through what we can understand about them. I don't know how the deep neural processing unit is defined, but we can look through some documentation of how it works. I think we're going to look at the accelerator first and then finish up with the DPU. I have some interesting documentation that we can read through. Let me see. Was this the, yeah, this is the, found the documentation for it. Open a block diagram here. And I didn't close that in the background. Okay. Now we have the accelerators. Most notably is this one at the top, the Vitis HLS. This is our PP pipeline accelerator that has 4 JEBs that are connected to this interconnect, and this is connected to one of the unused ports previously on this interface. This 0, which was previously connected to that virtual interface, is now connected to this interconnect, which is connected to the accelerator, and has the Xilinx validation block again, and then the DPU. So, I mean, let's see what happens when we click this, right? What pops up? We have a bunch of things we can change about it, or can try to change, but these are just the interfaces on, I think, the gems. These look like dev register, Axiom register. Not terrible. Yeah, looks like you can just change the configuration of those buses. So then, if we want to look at the code for that, go back here, or in the overlay. I remember where they put the code for that. Right here. Here is the file that defines what the pipeline is doing. I don't know these libraries well enough. But it looks like they're generating matrices, depending upon color, bringing some utility objects, formatting the matrices into arrays. That is looks like a color changing. This is probably the thing that's adding the bounding blocks, right? Resize, preprocess. I don't know these functions, but essentially they're doing some type of probably bounding block somewhere. But yeah, this is the accelerator, and they use the HLS to build that accelerator block. And now we're going to talk about, I guess, the most interesting part of this is the deep neural processing unit that the Vitis AI uses. And you can't see anything here. And if we want to look at the file, so one of the projects is a wrapper around this file. So this kernel pack is a wrapper around the DPU, the deep neural processing unit, DPU. Can't remember that name. Deep learning processing unit. It's a deep learning processing unit. And if we want to look at the source code for this this system here, we can right here. Here's the Verilog file that you would hope. It's an encrypted file, yeah. So can we open it here? I think we can open it. IP right here. We can go to HDL right here. And here is how they encrypt a Verilog file. So your data processing unit is encrypted. And this is part of Vitis AI, and I need to get into it to understand it a little bit more. But I do have some diagrams that I find of that Vitis AI documentation that we can look through real quick. I really wish we could get a little bit more into this. But yeah, so this is where the DPU comes in, the deep learning processing unit. You can use these frameworks that people are familiar with. PyTorch is pretty easy to use. I've used that before. I've done some simple examples in Caffe and TensorFlow. And then they can use this to generate your DPU. And the DPU, they got some really cool stuff in here. I wonder where the Kira would fit on this. The Kira is Zingle MP sock. Probably low latency, I assume. Yeah. DPU number. So let's go back here, right? So we have the DPU CZ the XAG V333. So we have a CNN. The ZD is the Zinc DDR. X is decent, I guess. We're using an 8 for 8-bit and general purpose. Okay, so that's one we're using on this design. Here's the architecture. They have, it looks like they kind of have this system where they do different layers of your neural network at a time, where they can have these different biases, rally and pooling, and then wrap it around and keep it and be able to rapidly. I think they're using this DMA controller to quickly switch out the weights in here as they do different layers of the neural network. Okay, here's the exact one we have in our project. It definitely has more units per se. But yeah, so that's kind of a dive into what the hardware is inside the Kira board. I need to learn how they do the whole Vitis AI approach. I'm definitely more of a hardware approach person, and going through this tool chain is new to me. But definitely they're trying to, I guess, approach this from more of a software perspective, giving a platform where software can easily adapt and use this platform, where someone makes a quick platform and then software engineers can make a different overlays rapidly. I do think that these three examples, right, the smart camera, the AI box, the defect detection, and smart vision, they're using different they're using different, I guess, platforms. Like, if I go to creating this hardware, it just says use the name. Yeah, I wonder how different these platforms are. But they should be more or less the same. But then the difference in how that's being processed, CPU interface and the pre-processing. Oh, the bounding box is a little bit different where the bounding box happens. Might be in the processor. Yeah. Configurations. So I guess the goal from here is we're going to there are Vitis AI tutorials, right? So Vitis AI tutorials. So I guess, oh, we got a new location. Is that I need to do some of these tutorials here to understand how we use the Xilinx DVU Accelerator and how we can use it effectively on this card. Unfortunately, I don't think Xilinx has given any good tutorials in creating your own platforms, your own overlays at the moment. But we can show you the Jupyter page. That would be something interesting. So let's finish off with the Jupyter page to see how software interacts with this hardware portion. So go to Quick Start, scroll, Smart Camera, go to Setting up the board and application, scroll down to the Jupyter page. Yeah, we want Jupyter Lab. Copy. Go to our Terra term. And I think 192.168.1.122. Okay, so that was not the address. Let's try this again. So the correct address was 120. And there was a okay. So what we want is there should be a token generated. Edit clear buffer. If we go up here and we type in 192.12020, cool, we're in. That's the smart. We don't want to go to the smart vision. We want to go to smart cam. There we go. And I really like the IPython notebooks and labs. They really have a way to interact. Okay, it's just a dot graph. That's the library. Construct the pipeline. So let's see how they're doing this pipeline. So they're switching between the USB or the media device. Grabbing the source still, grabbing the source. Construct the real pipeline. So this is probably, so I've done some video pipelines before with partial reconfiguration. So that's where we're getting the MIPI interface. We got the pre-processed JSON. This is the do color conversion. Yeah, that's what we saw in the preprocessor. Yeah. So config directory preprocessed JSON. Is that, let's see, is that in the overlay examples? Mark I don't know. Ribs. Let's see, right? If we can just search. We just search this GitHub for. I guess they don't have that in that document. And I'm not sure where that was installed into the device, because it would be nice to know what the JSON is actually doing. Detailed configuration, please see the JSON file. I would like to know where the JSON file is. Maybe it's in the generated files. We go here, we open up our SFTP, and we want to go to right there, Vitus, the overlays. I wonder if it generates those JSON files, the examples. I mean, let's see here. So, oh no, yeah, it would be over here. CKV find dash name star.json. See how many JSON files there? Yeah, that's what we expected. Process. Pre-process. So it's not seeing that JSON at all. Great, I want to see if we can hunt that down. All interface. Yes, we can see I bet it's not going to be in here. It might be related to something else. Right, so we're at the top of the world. Oh, look at here! I found it. So the opt Xilinx share. Let's go look at those. At the face detect. Oh yeah. So cd opt Xilinx share ibis smartcam preprocess. Oh, right here. And cat the preprocess JSON. That sounds like a wonderful idea. Face detect. What else we got here? Draw results, preprocess JSON. Okay. So it's actually a lot simpler. Oh, this is the XCL bin file that comes from the bin. So it's probably not human readable. And just some very basic configurations for that device. So let's look at the XCL bin file. So when we generate the overlay, right? It should generate an Excel bin file. So that's going to be over here. So go overlays, examples. We want to go to smart cam. We want to go to the binary container. So this is where the project is. And we have the bin file. So any XCL bin file, ls-a star XCL. Cat, so this is different. So this doesn't have any of the accelerator information in it. Blocks, memory configuration, the ports, instance, and ports. Yeah, okay, here, pipeline accelerator. Okay, so we have the values, and then we have the offset addresses to change those values. So I guess that's where you can do that stuff. Okay, so find a little bit more information. So somehow I don't really know what's happening here, right? So we would have to figure out. Let's see, I'm not sure if a quick Google search is going to answer a question. I don't think it is. This is something Xilinx has up and going. This is Hacker.io talking about it. Yeah, so that's a Xilinx library that's doing those tools, and we don't have any information about it. But it's taking this JSON configuration file, and all I can really guess is it's taking those values that we saw earlier. It's taking right here. It's taking these values, mean, scale, and whatnot, and it's writing to the registers in the pipeline. I don't really see where these colors would go. No, yeah, there's not really a place for them, right? We have this configuration. We have these addresses. Height, line stride, Yeah, they don't really match with the configuration values. So yeah, that's an interesting question of how that configuration file is doing anything useful. The AI interface. Okay. The AI interface. The JSON we're looking for, right? It said it should be in the same directory, but oh, I guess it is. So cd Xilinx. We're not inference. Oh, AI inference. I wonder if this is all the values. That'd be interesting. Share IVIS. Oh, IVIS. So this is probably where the commands are stored. Cam cat AI internet. AI inference. Model path. Oh, that'd be interesting. So the model stored somewhere. So let's go explore that. Right, we're in the share folder. Vitus AI. Go to the models. What models do we have loaded up here? We have these ones. So this is, I assume, the coefficients for the neural network and the structure. So dense box is what we're doing for the face detect. Can we cat this? This sounds like a bad idea. The director. Oh, okay, sweet. Prototext. I feel like I've seen the prototext before. So let's cat prototext. I feel like I know I've heard of that extension before. Prototext. Number of classes, threshold. So we have no face and face, and that's what we're looking for. And we need to have a 0.9 to understand the face, and the mean and the scale values match to what the preprocessors are doing. So I guess the preprocessor is basically making the image into the input of the neural network. Let's cat the model. This probably won't end well, but why not? Yes. Yes, the SSH went down. We're still here. This is still running, so let's SSH into it, and this time try to copy the file over at Xilinx. Do I have SFTP? Really? That's so sad. Someone should install that for you. Sudo apt get open SSH. Okay, maybe another time. Man, why can't I remember how to do this? Okay, we'll figure that out another time. Guess we could try to SCP it. That's gonna be pain. I wonder if that model. So let's. This connection's a little bit slow. Let's see if we can find that dense box. Okay, cool. Sure. Here's probably a good place. We're gonna find dash name, induce X model. So it's not there. I guess we'll less the other one. Flash op, Xilinx, share, Vitus AI libraries, models, SmartCam, dense box. Okay, we're back here. Let's less dense box. Okay, it's a binary file. That's what I thought. And then what about the yeah. Okay, so the coefficients are probably stored in the dense box and are in the X model, and it's being used like that. Let's see what these ones look like when it comes to the prototext. Okay, this one's a little bit more complicated than the prototext. Classes, finding different. Interesting. I think prototext is cafe. Can't remember. That might be the cafe neural network tool. So yeah, so what we need to do is at least I need to do some Xilinx AI tutorials. Here. introduction at this. Yeah, basically try to go through all of these tutorials and get them running on this board. I think that's probably the best place to start, and we'll probably run it with independent data and not use any of like the camera inputs or anything like that at the moment. And then I wonder if the DPU is like the ASIC that they're running in the Versal, if it's just the soft-cored version of it. That'd be really cool. I want to get one of these boards. I need to get one of these boards. It's only $12,000, you know? Very affordable. Um, okay. Wonder. Real quick. Video, USB camera. Maybe that. This is going to be a blast of stuff I'm not used to. Okay, so we install that, install that. Uh, so do I need to go Docker? I haven't used Dockers before. Maybe. It's probably just like us help out with getting the tutorial up and going. Modules. Detailed image, module 2. Code. Yeah, I mean, this stuff doesn't look like it's necessarily going to help me at the moment understand how to get this working. 2.3 cross compiling. What's module 4? Okay, okay, yeah. Dense net. Limiting the design. Vitis AI. Okay, okay. Yeah, we can. It seems like train the module. Okay, comparing it to evaluating, contemplating, the quantized model, combining the quantized model, application on the board, running the application on board. So does this generate hardware? This must generate the hardware, right? Yeah, the X model format that we were looking at. Yep, yep. I guess we'll have to look at the user guide. Yeah, this is much more complicated than I wish good tutorials on that. Not bad, not bad. I don't know what GPU they ran these on. Oh, the threads of what they're going to do. For practical use data. Okay. So, yeah, at least that's the basic tutorial, and then there's more full-fledged documents of maybe trying to get this up and running with Vitis AI and creating the DPU unit that then is put onto the device. Station, main application. Ruining it. Yeah, this is interesting stuff. I just hope they start adding more tutorials for the Kira board. Okay, I think that's going to be it for today. I know this is just trying to dive into the different things that the Kira is using. But hopefully we can dig more into it. Um, it and maybe we can do a little bit more better organized videos. I just want to get a video out real quick of what the Kira is doing and how it works. But so I guess look forward to videos where we'll be looking to Kira. I plan to do kind of some basic hardware designs on it to see what we can use that way. I don't know what we can do for that sake, because I have the new Vivado, and I mean, there's not a lot of interfaces that can be used. We have the 3 camera interfaces, RTC transmitter and receiver. Not even sure what that is on the board. And a switch. Yeah, so there's not like a lot of, I guess, FPGA I/O that we can take use of this board, but maybe we can do some video processing like we did on the Pink, and maybe bring that over to this project where we do some video DMA and maybe try to encode it, try to do something completely outside the AI interface to understand how the VCU works. Like if we wanted to create our own video, how that works, how to make get the video displayed over the DisplayPort or HDMI. That would be some fun bare metal stuff to look at. So there's different things to look into. Well, thank you for joining my stream. I see that I've lost most of the viewers at this moment. I mean, that's understandable. Well, have a great night.